Hi there, and welcome to this lesson on Pure Mathematics 1. We're up to Chapter 2, Quadratics, and in this lesson we'll be looking at quadratics as functions. First of all, a few quick reminders about functions. A function has a set of inputs, those are just the x values. That set of inputs is called the domain of the function. It also has a set of outputs, those are just the y values, and that set is called the range of the function. Instead of writing y equals 3x squared plus 8x plus 2, we'd write f of x equals 3x squared plus 8x plus 2, where y is written as a function of x. And on a graph, the x-axis would stay the same, still label it with an x, but the y-axis becomes the f of x axis, and you'd label it as f of x. For nearly all purposes, you can regard these two ways of writing things as identical, and frequently I will interchange between these two ways in the middle of a question. For many questions, it really doesn't matter which language you choose to use, but for some it does. It just makes life slightly easier if you choose to use one rather than the other. They'll talk about the roots of a function. The roots of a function are the values of x for which f of x is equal to 0. Now that means exactly the same thing as when you have an equation and you solve the equation, and you solve it for when y equals 0. Okay, an example for you to have a go at. This gives us two functions, f and g. F of x is 3x minus 5, g of x is x squared minus 15. We're told that x is a member of the real numbers. That just means that x can be any normal number. First of all, find the values of f of 4 and g of 4, and then solve this equation, f of x equals g of x, and they suggest that you use factorizing to do that. Pause the video, have a go yourselves, then come back to me. Okay, we'll have a look at these together. So, question 1 says find the values of f of 4 and g of 4. F of x is 3x minus 5. To find f of 4, we just substitute in 4x, x equals 4. That gives us f of 4 is 3 times 4 take away 5, which is 12 take away 5, which gives us 7. To find g of 4, we look at g of x, which is x squared minus 15. G of 4 means we substitute in 4 for x, which gives us 4 squared, take away 15. 16 take away 15, which is 1. That's part 1 done. Part 2 asks us to find the values of x for which f of x is equal to g of x. And the suggestion is that we use factorizing to do this. If f of x equals g of x, we just substitute in for the two functions. So f of x is 3x minus 5, g of x is x squared minus 15. We say those two things have to be equal to each other. That gives us a normal equation. We solve it in the normal way. Rearranging it would give us that. They suggested factorizing, and it does factorize into x minus 5 times x plus 2. And that'll give us two solutions. Either x minus 5 equals 0 or x plus 2 equals 0. If x minus 5 equals 0, that gives us x equals plus 5 for the answer. If x plus 2 equals 0, that gives us x equals minus 2 for the answer. Okay, a second example. Got a different function now, x squared plus 8x plus 13. Again, we're told x can be any real number, any normal number. First of all, write f of x in this form by completing the square, and then try and find the roots of f of x in surd form, and then finally see if you can write down the minimum value of the function and state the value of x at this minimum. Again, have a go at doing this yourself, pause the video, come back to me when you're ready. Okay, let's have a look. So part 1 asks us to write the function in that form. And that is the form that you get when you complete the square, if you remember doing that. So you start off with a function, x squared plus 8x plus 13. We need to get a squared bit in brackets. That'll begin with x, and the number will be half of 8. So you get x plus 4 squared. Now if I squared that bracket, I would get x squared. I get 4x twice, so I'd also get 8x. Both the first two terms work. I'd also get 4 4s. 4 4s are 16. I don't want that 16, so I need to take it away. I do want the 13, so I need to add that on. Tidying that up would give me x plus 4 squared minus 3. That's in that form. So we've now completed part 1. Part 2 says, hence or otherwise, find the roots of f of x in third form. A couple of comments here. If ever you see in a question, hence or otherwise, what the question is saying, and this frequently occurs in exam questions, you can answer this question easily if you use part 1. There may be other methods to do it which you're allowed to use, but they will be harder and longer. So they're really giving you a very big hint. There's an easy way to do this question if you use part 1. Finding the roots of f of x means finding the solutions of when the function is equal to 0. In third form means we'll be leaving square roots in the answer, not writing a decimal. So to find the roots, we say f of x has to equal 0. That is f of x, x squared plus 8x plus 13. That has to equal 0. That we need to solve. This is where the hence bit comes into play. We already know that we can write that in this form from part 1. So we do that. Then we move the 3 to the other side. Then we find the square root of both sides. That gives us x plus 4 is equal to plus or minus root 3. And last of all, the 4 swap sides. That gives us x equals minus 4 plus or minus root 3. And writing them as 2 separate roots, we'd have x equals minus 4 plus root 3 and x equals minus 4 minus root 3. And those are the answers in third form because we've still got square roots in the answer. Now, a very important application of completing the square, which is very, very common in exam questions. If they ever ask you to find the minimum value of a function, probably the best way to do that will be completing the square, as long as the function's a quadratic. If it's not a quadratic, you will need another method. Now, there's the function having completed the square. F of x is equal to x plus 4 squared minus 3. That's what we did before. Now, a very important piece of logic. If f of x or anything is equal to something squared plus something else, the minimum value of this is b. If a squared is equal to 0, if a is equal to 0, then a squared will be equal to 0. And that is the smallest a square can ever be, because a square can't be negative. A square is always positive. It's always greater than or equal to 0. So if ever you see something squared, the smallest that can be is if that thing squared is 0. So for us, it means the minimum value of this function will be minus 3 when that bracket squared is equal to 0. Now they also ask us to state the value of x at this minimum. Well, that's the value of x that will make this bracket equal to 0. If x is minus 4, we'll have minus 4 plus 4. That's 0 squared. That's 0. That's as small as that gets. So the minimum value of the function is minus 3. That's the y value. That happens when x equals minus 4. Now what you've got there are the coordinates of the minimum point if you were drawing a graph. The coordinates would be minus 4, minus 3. Okay, last example. We're still on quadratics, but it doesn't look like we are. Example 3 says, find the roots of f of x equals x to the power of 6 plus 6x cubed minus 16. Again, where x is a real number. Now have a go at doing this yourself. We're doing quadratics. What that means is there is a way to convert this into a quadratic equation. See if you can do it yourself. Pause the video, then come back to me. Okay, we'll have a look at this. There are 2 ways of doing this question. Both are equally valid. Some people choose to use one, some people choose to use the other. They are really the same method with just a slight twist in them. First of all, we'll consider what would happen if we used a substitution. And the substitution is we're going to let y equal x cubed. Now, the moment we do that, you'll see why we've done it. X to the power of 6, well, that'll be y times y squared. X cubed is just y, and 16 is 16. So if we let y equal x cubed, this function becomes this. That really should say f of y now. F of y is equal to y squared plus 6y minus 16. We've changed it into a quadratic. Once you've done that, you just do all the normal things that you would do with a quadratic. So to find the roots, we have to let that equal 0, which means y squared plus 6y minus 16 equals 0. That does factorize into y plus 8 times y minus 2 equals 0. If the first bracket's 0, we'll get y equals minus 8. If the second bracket's 0, we'll get y equals 2. Then we have to substitute back again. You always have to do this if you choose to use a substitution. Y was never in the question originally. Y was x cubed. So at this point, we change back from y to x cubed. So x cubed could equal minus 8 or x cubed could equal 2. Now, if x cubed is minus 8, that means x is the cube root of minus 8. If it's 2, you get the cube root of 2. Now, the cube root of minus 8 we can do. The cube root of minus 8 is minus 2. The cube root of 2 is a decimal. Better just to leave it as cube root 2. And that would be the answer using that method. Method 2. It's the same method, but it requires you to have a little bit more confidence, a little bit more bravery. You never bother with the substitution. Instead, you just notice that you could rewrite this. Still doing the same thing. We're saying, when does the function equal 0? Rather than using y, you could rewrite this as x cubed all squared plus 6 times x cubed minus 16 equals 0. Now, the x cubed in purple is the variable there, and you just treat it like you would have treated y in the previous question. So factorizing it, you get x cubed plus 8 and x cubed minus 2 in the brackets. That means either x cubed is minus 8 or x cubed is 2. Same as before now, that gives you the cube root of minus 8, the cube root of 2, which is minus 2 or the cube root of 2. Now, as I said before, I think use whichever method you find easiest to understand and easiest to do. So you either do a substitution where you choose to say y equals x cubed, or you choose not to do the substitution, but you just use x cubed as your variable in the question. Okay, that gets us to the end of the lesson. If you've got the textbook, turn to page 26 and have a go at exercise 2E. Thank you very much for listening, and cheerio.